In this problem, you simulate a spinning disk that's used for speedometers and such. So we get a bunch of measurements, a sequence of zeros and ones, and whenever there's a transition from a 0 to a 1, like here, then we know that we've crossed the boundary, like a boundary here. And when there's the opposite transition, then we're at this other end here. So we need to sense these transitions, and the trick to do that is that you keep a variable last input, and now when you process a new input, then you compare it to the last input. Let's assume this has already started for a while and we are at the point over here where last input was 0. Then input comes in as 1, and now we can see that they're different. And then before doing anything else, we're going to be sure to move the input into last input so that the next time around when we're at this set here, that we can now see that the next input will be 1, that those inputs are the same. All right, so that's the basic idea. Now let's see what we're supposed to be tracking here. We need to find how many of these transitions we had, and we're supposed to find out the length of the current segment. So let's first of all do the transition count. It sounds a little simpler. So every time that we have a transition from a 0 to a 1, or from a 1 to a 0, we need to update a counter. So we have now these two variables, last input and input. And let's see what the various combinations are in which they might occur. They could both be 0. One of them could be 1, or they could both be 1. And now in the case that they're both the same, we don't want to do anything. So we want to increase the counter by a value of 0. In the case that they are different, we want to increase the counter plus 1. So how do we get a 0 when they're the same? Well, that seems like if we subtracted them, that would be good. So let's look at that. When we subtract 0 and 0, we get 0. 1 and 1 is 0. We subtract 1 and 0 here. That's good. That gives us the 1. Unfortunately, here it goes wrong. 0 minus 1 is minus 1. But that's not fatal because we can take the absolute value. If we were to take the absolute value here, then that turns this one into a plus 1. And so we're done. So really what we need to do is we say the counter is the counter plus the absolute value of that difference. And that's the code that you find here. So again, I put this into a separate variable called change, and then I added that to here. So you can see that works nicely. No if statements are required. Now what about the segment length? Generally what I want to do is I want to increment the segment length every time something new gets added. So I basically just want to say segment length plus plus. That should happen, for example, here, here, and here. But when there is a change, then I want to set the segment length back to 0. So let's see. So if there is a change, I want it to be 0. That's easy enough to do. I know when there is a change. This thing here was just called change. Now the change is 1 in these two cases when I want to make the change, but that's not fatal. So I can say the segment should be one minus the change, because this thing here will be 0 if the change is 1 times segment plus 1. So when change is 1, then segment will be set to 0, and if when change is 0. There was no change. Then the left-hand side of the multiplication is 1, and I get segment plus 1. So that's a clever trick of manipulating these variables so that we, again, don't need an if statement. And that's the code that you see here. And finally, as I've already said, at the end of the add method, we want to set the last input to the current input so we remember it for next time. And so that's an important thing that you should remember about the spinning disk here. Look at its instance variables. So it remembers these two things that we wanted to remember, the segment length and the transition count, and it also remembers the last thing it has seen. What's somewhat remarkable about the spinning disk is it doesn't look like a disk or anything. It's just 3 numbers. And that's how it is. This is, of course, not an actual physical object. It is some memory in the computer that simulates the behavior of a physical object. Have a quick look at the constructor here. It just sets them all to 0. And there's 2 accessor methods down here. And that completes the code.